my name is Chris. I'm a freelance motion designer from London, and today I'll walk you through this cool twisted vellum effect that's inspired by Windows 11 hero images. To start off, I'd like to break down this project into kind of smaller, more manageable chunks. At first, we'll start off by kind of building our geometry out. This would involve creating our individual sheets, arraying those out into sort of a more chunky bit of geometry to work with, deforming that, twisting it around, and creating a custom velocity attribute from it. Then we can move on to the simulation step, where we start off by kind of getting our constraints and our settings for our cloth set to where we want it. Then moving into the DOP, the simulation area, and importing our velocity attribute that we created prior to this into the simulation itself, so that when we do simulate, it reads the custom velocity that we've built, and we get that cool kind of twisting motion out of it. And then finally doing some post-processing and making it look a bit more smooth and more pleasant, right? And then right at the end, I'll go over some extra stuff, just detailing like colors, setting up colors with a class attribute, and other little things like other setups and like cool things you can do with arrays, or the way I've done arrays in this project. Okay, let's get started. First of all, let's start by making our sheets. So let's make a geometry. We'll just name this Vellum for now. And let's start making our sheets. So we're going to start with a grid. We are going to set the orientation of this and the scale. We're going to set this to YZ, so we have it facing this way. Right. Then we're going to set the scale to the size to 0.72, 1.2. Right, so we have kind of smaller, within the bounds of 1 on our grid, and that will be our starting point, right? We're then going to come off of this and we're going to remesh. Because Vellum tends to like, cloth sims in generally tend to like triangles, and we want it a bit more high res than this, so I'm just going to up it to that, right? We're then going to center this. And we're going to set the justification to min, because we want it to be sitting right on top of our origin, right? Yep. And then let's stick some UV textures on this. Right, if we click, oh, it should be visible, our UV textures. We set this to our X. Yep, there we go. So now we've got UVs on our sheet. Right, next we're going to put a transform down. And we're just going to scale this. I'm going to go 0, 1, 0.8. Technically, probably don't need to do this. You could probably figure out how to just do this in your size, but when I originally did this, I had another setup using a wrangle for something we'll get into right at the end of the video in the extra section to do with arrays, but this is how it was kind of done through a different method, and I'll explain that a bit more later on in the end of the video. But yeah, so this is our sheet, and then this is our sheet done. So let's stick this, we're going to call this our sheet. Yep, Right. Now let's move on to getting our array set up. So there's a ton of ways to do arrays. The way I did it in this was just to sort of make a bunch of points. So I'm going to do an add 1 point. So we have a single point here. Right. Have a point, let's make it a bit more visible. Right. Yeah, so we have our point. And what we're going to do is we're just going to copy and transform. And we're going to make a total of 10 points and move them across 0.01. Right, so we have a kind of a line of points. You don't have to do this way. You can, if you really wanted to, for the next step, you can make this 20 points and then transform or center. So there's two ways of doing this. You can do it this way, center them, so we have a center, or the way I ended up doing it was by, let's just make this two different routes of how you can do it, right? So we can do this way, copy 20, translate the same amount and center it, or you can do it the way I did it, which was I did the 10 and then I literally just did a mirror, right? And I set the mirror, yeah, mirror was default the same, right? All the same stuff. Probably don't need this. The way you check if you need that or not is if you're here and in the middle you see two numbers overlapping. I believe there's numbers overlapping there. There you go. So untick only consolidate on shared edges, because last thing you want is you don't want two sheets on top of each other, right? So that's done. This is our array. Either one should work. They're slightly different, but pretty much the same thing, right? Doesn't really matter how many points. This is down to personal preference. However many sheets you want, that's how many you put in, right? This is our array. And when we get down to the extra stuff, we'll set up kind of like fall-offs, and we'll use a wrangle to kind of scale each of those sheets, however, by a profile. So we could profile this to be more in line with the sort of last clip in that video, right? So what we do now is we just set this into a copy to points, and we set this in here and this in here. If you push Shift S, you can get nicer lines. Yeah. And now, if I turn those numbers off, now we have sheets. Right. We have a bunch of sheets. This is the start. Now we move on to deforming, right? And we start that by using a simple bend node, right? And the bend node settings are going to be pretty simple. Let's start with our capture, because this is kind of, if we look here, if we click on our gizmo in the viewport and we press G, we can kind of see what that's going to do, and see at the moment it's orientated the wrong way. We want it to be pointed. We want this box to be up here. And the way we do that is by changing our up vector, I believe. Yep. So change up vector to 1, 0, 0, which will rotate it this way, because we're going to be twisting it this way, right? And we're going to be bending it that way as well. So we want it to be like that. We want our capture origin to be our captured direction, sorry, we want this to be 0, 1, 0. And we want our capture length, we want this to be the same as our grid height. So we want to do copy parameter, paste relative reference. So this should be 1.2, the same as this. Yep. And you can see now, this now perfectly lines up with the top of our sheets. Now if we decide later on we want to change the length of this, right, this will always match, which is why we do that. Right. So this is the setup for our deformer done. Next thing to do is to add the settings. Now we want to bend this across so it kind of makes an arch, and then we want to twist it. The settings are pretty straightforward for this. It's just 180 on the bend and 360 for the twists, and that's how we get our twists, right? Yeah, let's move that off. We have a nice twisted sheets, right? Now, going back to why this transform is here, if we remove this, you can see that it cinches really tight here. And when we keep it, it doesn't cinch as much. And we don't really want too much cinch in here, because when we do simulate this, these are going to be really tight together, and it can cause sort of collision problems. And we want to try and avoid that as much as possible. So it might be the case that when you're simulating, you're noticing there's a lot of bits sticking here and sort of collision errors happening. The trick would be to just reduce your scale on the Z, which kind of like, it just sort of makes it less cinched in. All it's doing is just thinning this out, right? Because the wider this is, the more the sheets kind of come down to a point when they're twisted. So just be aware of that. You might have to tweak yours if you're doing slightly different settings. This might be an area you want to keep an eye on, because this is where it can sort of break and be a bit kind of funny. But yeah, so that's our deformer basically done. But what we're going to do is we're just kind of make this into the shape that's in the video, right? So the way we do that is we just we're going to do a transform, yeah, and we're going to scale this a little bit. So, and all of this stuff is basically just getting it to the look that I want. So this is completely up to you. If you want to make it look slightly different, make it look slightly different. If you want to put more twists in there, put more twists in there. But just be aware that if you're twisting it loads, you might have more problems with like intersections. So it is really striking a balance of like having enough space in between these sheets so that when you sim it, you're not running into collision problems, right? And for this, we're just going to do a scale, and we're going to set our scale to 0.8, 1, 1. Yeah, so I've just kind of squashed it a little bit, right? Then we're going to mirror. And we're going to set this to 0, -1, 0. Yep. We're going to consolidate again, and we're going to only consolidate shared edges. I do like to double check this. So again, I go display point numbers. I tend to go in, and I just make sure that where that seam is, there aren't any sort of like doubled up numbers, right? It looks like we're good. If we don't consolidate seems to be good as well, so you probably don't need to do that. But if we don't consolidate this seam, you can see we've got like 2 numbers doubled up on each other, so we definitely want to sort of like fuse those together so that they're just stuck together essentially, right? Now this is all one piece of geometry, which is what we want. Then what we do is we're just going to rotate it around. So another transform. And we're just going to rotate this 90. Yep. This is our starting shape. Nice. Could put this in a little container. Call this our deformed geo. Yep. Cool. So let's move on to creating our custom velocity attribute. This is where we're going to get the movement of this kind of twisting around in the sim. It's actually quite simple how we do this. All we're doing is we're taking our sheets that have been copied and we're going to run it through pretty much the exact same process. So what we're going to do is we're going to take this, but we're going to add a transform before everything. And what this transform is going to do is we're going to rotate this thing by however you want to animate it, right? You can animate this however you want. It's your velocity attribute. You can make it rotate round, rotate stop, rotate backwards, do whatever you want. I just did $F, right, for the y-axis. So all this is doing is it's just rotating our sheets around like this. Yeah? And then here comes the easy bit. We're going to grab our bend, our transform, and our other transform. We're going to hold Shift, Control, Alt, and drag. This is going to create those nodes referenced, which means that whatever we do to these guys will update and match whatever these ones are, right? So this is just going to give us the same shape, but it's going to rotate round. And this already looks cool, right? But we're going to run this through a sim. So what you do next is we need to turn this geometry and get a velocity attribute from it. So we do that by doing a trail sub. We're going to set our trail down and we're going to set this to compute velocity. Now what this is going to do is if we click on a little eye and we visualize our velocity, we're going to get a velocity attribute that's kind of following the rotation of our geometry. And we can use that in our SOP to essentially push our sheets round and twist them more, right? I did do an attribute delete at the end of this just to clean things up, so this is not necessary, but it's a good sort of like thing to do to keep your work optimized. So do an attribute delete, and we're just going to keep everything. Well, we're going to delete everything and keep only the velocity, right? So delete non-selected, and we want to keep our point attribute, our velocity, which is this one. See, point attribute, velocity. We want to keep that. Stick a null on the end of here, and we're going to call this our out velocity. Yep. This is our custom velocity. Let's move on to the next stage, which is simulating, right? So let's stick down a Vellum cloth, configure cloth. We're going to plug our normal static geometry into this. We're going to view it because there's one thing we want to make sure is happening in this node. Now, depending on how many sheets you've done, this might be different. So this is why it's important to check. With a Vellum sim, we have something called a thickness scale. This shouldn't be called edge length scale. This should be called thickness scale, because an edge length is these edges here across the surface of the geometry, whereas thickness scale is really kind of the other axis of that. So where we have, if you imagine like these are tangents, the thickness scale is a normal, so it's the length of a normal. So if we visualize this, we can see that we have a bunch of circles appearing on these points. All this is just telling us how thick each of these sheets are, and we want to make sure that they don't overlap at all, or kind of get big enough where they would overlap. We want to make sure that there is a gap between all of these, right? You can see you don't really have to worry too much about down here because these bits are going to scrunch together anyway. But if you're running into problems with like bits of vellum like breaking and doing weird stuff, it's most likely because the thickness is too big, or you need to kind of like separate these sheets a bit more. So I think I was able to leave mine at default and it was fine, but this may be an area where if you're running into problems with your sim and you're getting weird like collision problems, this is the setting that you want to decrease. Your edge length scale, or should be called thickness scale, because this is essentially where it's getting confused. It's getting confused because it's like colliding with itself, right? Other settings are pretty simple, and again, you can tweak these however you want. But I'll run through what each setting kind of does so that you can play with them and see what you want to do with it, right? So stretch. This is how much each of these edges, let's turn this off actually, this visualize thickness. Each of these sort of white edges, stretch refers to how much they can get bigger or get smaller. So, or how likely they are to, right? So how much can they stretch? How stiff are they? How much can they not move? So I set this to 1e.9, so I want it quite rigid, right? So if you go all the way down here, if you go down here to 1e minus 10, this is going to stretch a lot. So this is going to stretch a load. So you kind of want to, for this, I wanted it to be quite a kind of rigid cloth, so it doesn't stretch too much. It wants to be kind of strong. And then our rest length scale is how much of this length at rest. So when the cloth is kind of settled, this is all right. So the best way to put this is kind of like a multiplier for our edges. So let's say this edge's length is 1. If we leave this at 1, this means that the value of our edge will stay at 1, right? If we set this to 2, when we start the sim, this edge is going to want to get to its rest, which would be a times 2 of this edge. So this is at 1, but when we hit sim, this edge is going to grow to hit 2, right? So it's going to expand our cloth. I wanted it to expand a tiny bit, so I set this at 1.09, so it's a tiny, not 11, that would be crazy. 1.09, so it's just a tiny bit bigger. So when we start the sim, this is going to expand by 0.9, right? So our edge here is going to expand to a little bit out here. That's all of the settings for stretch. For bend, I believe I just made it more bendy, right? Yes, so I just turned this down to this one, 0.000001. And then for our rest angle scale, I think I just added I added 0.02. So again, what this does is it's, instead of stretching here, it's more of an angle thing. So it's how much can these edges bend. So instead of how long can they get, it's how much can they change their angle. So the less this number is, the more bendy it's going to be, because it's about stiffness. So the less stiff it is, the more it can bend and sort of wrinkle. This is how you get good wrinkles, right? Rest angle scale is pretty much the same. It just means that it's gonna sort of bend more at the start. Going to crinkle more, right? Now that that's set up, let's set our vellum solver. Normally I do a DOP, but I mean, this is such a simple setup. It's just very easy to just do a default vellum sim. This is going to compile our first frame. So we've got this in here. Before we do any settings in here, let's just jump into our vellum sim and let's get our velocity attribute in here just so that it's there and we don't have to worry about it. And the way we're going to do this is we're going to just drop a SOP solver down. There's probably a bunch of ways of importing your velocity in here. I'm pretty sure you can do it with a wrangle, and you just you input, and I think you can input your data through here. But I tend to like using the SOP solver because it shows me directly. I know for a fact it's going in. So we're going to do a object merge, and to tell you guys exactly what a SOP solver is, this is essentially just a way of bringing SOPs into the DOP network. So we're bringing our geometry in. So we're going to bring an object merge in, and we're going to import our, we can find it if we type in out velocity. That's what we want. So we want to bring our velocity in. So this, if we do this, see we've got our velocity here, right? What we want to do is we just want to attribute transfer and we want to put our, again, Shift S, we want to put our velocity attribute in here. And then what this will do is, if it's the one problem with SOP solvers, they don't like to thingy, we do that. Now we should see, if we play this, right, so this is the start of our simulation. All this is this is our geo. If we hide our velocity for now, this is our simulation, right? So essentially what this is doing is our simulation is doing its thing. Every frame is calculating, but before it finishes its calculation, it runs the sim through this and essentially does like a second pass, right? So it passes it through, adds the velocity on, and then it essentially kind of like redoes that frame with the new information it has. So we get kind of a thing, right? Now, I tend to do this for all of my sims. I tend to put down a wrangle. Again, this isn't necessary. You can do this outside of the DOP as well. But I tend to do it in the DOP. Don't really know why. I just, where I tend to do the experiment with the velocity and stuff. So I just kind of do it in here. So all we're doing here is we are adding a multiplier to the velocity. So when I first did this, the rotation, I wanted it to rotate more and more quickly. So the default velocity attribute that we made, I wanted it to be more powerful. So the way we do this is just by doing a vector at velocity. So we're just referring to our velocity attribute that we've imported through here. And we want to times this by a channel. And it will want it to be a float. So a channel is essentially just one of these, right? It's just like a scaling number that we can select, right? So, and a float means it can be any number with a decimal point. So integers are just full whole numbers, and then floats are kind of whole numbers plus every other little number in between. So we want to do a channel float, we want to brackets, and we want to do commas, and then we want to quotation, sorry, not commas. We want to just give it a name. This can be anything. I tend to call these mult. And then that's it. We just click we make sure we do our semicolon, and then we click this little button here, and we get a channel, right? I've set this to 3, so I want it to be 3 times as more powerful as our velocity. So what this is essentially doing is it's updating our velocity attribute by timesing it by whatever value. Oh, what have I done there? So we're updating our velocity by timesing it by whatever we set this channel to, right? So it's our velocity times 3. Call this Vellum. Right. And then we can come out. That's our velocity setup. What I do next is we'll tweak the settings in our Vellum solver. So I tend to always turn my timescale down, mainly because I can always speed up, whereas if you do something really quick, it's really hard to slow it down without having like problems, and then you have to like worry about interpolating and stuff like that. So I tend to always speed down, unless you want something really quick. This is kind of personal preference. I wanted this to kind of be a slow moving animation, right? And then I have this set to 3, but if you notice more errors, you can probably easily up this to 6 and it'd be fine. But I was quite comfortable with 3 with mine. And then the last thing is just set our gravity to 0. We don't want it falling through the floor unless that's something you want. Yeah, I think that is pretty much our solver done. Last thing to do is just run through some post-processing. So we can just drop down a Vellum post-process. And all this does is just sort of makes... Well, it does. We use it for 2 things, really, right? We use it to, if we want this to be a bit higher resolution, we can set our subdivision up. So we have sort of a more dense and higher resolution sheets. Detangle can help if you have weird like tangle problems that are happening through your sim. You can sort of try and fix them with detangle. If you don't have them, you don't have to worry about it. If you do, play around with this and you might be able to iron some of them out. If you're finding your sim is a little too crinkly and you want it to smooth out a bit, you can smooth it out with the spatial blur. This does lose detail though, so be careful with this. You kind of don't want to, you want to find a sweet spot where you have good detail and you're not losing too much of it. And then the one that is kind of like I use for most of these is extrude by thickness. And what this does is takes a little time, but it gives us some thickness to our sheets. And we can tweak this by, I tend to just turn the thickness scale down a little bit, right, to however thick you want it. I think I set mine to 0.08, so I did it even smaller, right? So it's super thin. But again, personal preference. Make it however thick you want it to make it. You probably don't need 8 on the divisions. You can. I had mine at 4. You can probably put it lower than that as well. And that is pretty much it. Last thing to do is When I did mine originally, I had some normal errors. So if you're having normal errors, just stick a normal node down. And let's see if we have them. Yeah, so we have some weird things happening on the edges here. So that just fixes those errors. And then yeah, after this, it's just setting up a cache, do a file cache, set up a file cache, name it whatever you want, Vellum sheets. I tend to, so big thing here is I see a lot of people putting like an attribute delete before. File cache actually has one inbuilt, so you can do whatever ones you want to keep. I tend to do whatever ones you want to keep. So P, if you want to keep your velocity attribute, keep it. I don't really think I use it for this and anything. If you want motion blur, maybe keep it. Other than P and the normals, I don't think there's anything else you'd want to keep. UV, definitely keep your UV. And then we just want to set these to uptick. Ooh. And we just want to do a star. So it's delete everything apart from these guys, right? And if you have groups in there, like these ones from our extrude back, so these I think are from our post process, we can delete those as well. So we might as well just delete all of them. And then cache it. And then when you're cached, so when you're cached, let's move on to sort of the extra stuff. Extra stuff being sort of like how we do arrays and or doing some sort of stuff with arrays where we can profile. So if we go back to our array, let's move this one out of the way. If we undo this guy for now temporarily, because what we're going to do in here is going to essentially do what this does. So we come back to this stage, right? What we can do is we can set a fall off. So a couple ways you can do this. If you have mops, I recommend using mops. If you don't have mops, I recommend using, there's a couple nodes that you can use called mask from geometry. So you can do mask from geometry, mask from target. These are essentially just ways of masking stuff. So if you don't have mops, you can use these guys. Essentially what we're just going to do is we're just going to make a cube. We're going to put it here. We have our points from our array originally. We want to visualize this for one, so we want to tick our mask visualize on. You see they've turned red. We want to let's just scale this cube down. Now you can see we're getting a little bit of orange here. But that's gone to 0, so we probably want this to be at 0.1. Let's set that to 0.1. Oh, we should actually put this below our mirror, sorry. Right, 0.1. So, and then we're just going to go into this and we're just going to tweak our radius. So we're going to have it like that. And you can probably still just tweak this to how you want your sort of like profile to be essentially. We can do distance from inside. This might give us a nicer fall off. It's more of a smooth fall off. Tweak this however you want, but this is essentially where we can tweak our profile. Next is we're going to stick down a wrangle. Attribute wrangle, and this is where we're going to scale our stuff. So what we're going to do is we're going to make essentially we're essentially going to make one of these, a scale with 1, 2, 3 values, right? So the way we do this is we do a float, and then we're going to call it scale x equals channel float. Do our quotations, and then we're going to do scale x, so that's what it's going to be called. We're going to close that off. We're then going to copy this, paste, paste, so we have 3 of them. We're just going to change this to y, this one to z. We're going to change our z, y, right? So we have three channels, right? So we've got scale x, y, and z. What we're then going to do is we're going to do this. The vector at scale is equal to, and then we're going to set our scale as these 3 values that we've just made. So we're going to do scale x, scale y, scale z. Right? So we're calling that off. And then if we look at our copy to points, we can see that they've disappeared, and that's because these are all at 0. So if we set this to 1, set this to 0.4, in fact I think I can set this to whatever this is, so let's just do it, let's do 1s across the board for now, right? We should have this. Now, you might be thinking, they're all the same, there's no profile to this. And that's because we haven't actually added our fall off into it yet. So the way we do that is we can add that fall off into any of these dimensions. So what we can do is we can say, I want this value to be whatever I set it as, but I want it to be affected by our mask. And the way we do that is we just do this. We do add our channel. We want this. We want our scale scale y to equal our channel times by at mask, and then that actually gives us a fall off on our thing. So if we want to fit this to be the invert of what it is now, because at the moment it's going 1, 0, 1, right? Our mask. What we can do is we can just fit the mask. So we can go, just do this before, we can do at mask equals fit at mask, comma, we want it to go from 0 to 1 to 1 to 0. And then that should change our profile. See how it's changed? And we don't have to have, because at the moment this is only affecting our y. And we want it to change, if we want to change it so that it affects every dimension, we can just times the end of this, and it should affect all of it. So you can see now it's scaling in the z as well as the y. The x isn't going to do anything because they're flat sheets, so it's not going to do anything to it, but in reality you could probably just eliminate the x and just say 1, and that'll be fine. You don't have to have your x in here unless you're doing this at like an angle or something, but it's up to you how you do it. This just gives you control of all of them, and then we can just go in here and just tweak our mask to whatever we want, right? This might look better with more sheets, and you can switch this to, maybe you want this as a linear fall off. We can set this up to be a bit more like this. Maybe we want more of these. Maybe we set this to like 50 sheets, something crazy, right? That way, when we copy, we might just have to make our cube a bit bigger to accommodate all of those points. So we want, I have to visualize our cube and our points, and then see, we've got to change our thingamabob, change our fall off. So you can just tweak these until you kind of get what you want, right? And that way you can kind of build a kind of array of pieces that you want, right? Little pyramid. And again, you can change this to, maybe you want Bezier, maybe you want it to be kind of rounded. You can kind of tweak this curve to fit whatever kind of shape you want. Let's say we want to color these how I colored them, right? So just want different colors across. Easy way is to just stick a connectivity, right? Stick a connectivity. If we visualize what this does, it's just making a class attribute. We've got colors, right? But we want to bring this into an actual color attribute. So we can just do a color node, stick that there. Let's unvisualize this. We can do it a couple ways. We can do it random from attribute, and then we just put our class attribute in, and then we can just kind of tweak whatever colors we want. You could probably animate this as well if you wanted it to flicker in and out, or you can ramp. And if you know how many pieces you have, right? Not really sure how you would do that. How many points do we have? We have 10 points, right? So that means we have 10 instances. So we set this to 0 to 10. If you go in geometry spreadsheet, you'll find it as well. We can now then, I believe, I'm pretty sure there used to be a thing that lets you, if you can just tweak these to whatever you want, right? So you can change your colors. You can have fun with it, right? You can just sort of play around. Don't know why it's only doing half of it. There you go. Set it to 20. And you can mess around with your colors, do whatever you want with them, right? Have fun. And then voila, sim it, and then you're done. Stick it in your render engine, and you've got cool Vellum twisted sheets. Thanks for watching. Please like, comment, and subscribe. And here's a little teaser for my next tutorial.